Hey everybody, welcome to the last day of Daily LeetCode Challenge on May 2022. We are going to solve problem 146 today. The title is Check if a string contains all binary codes of size k. We are given a string s and the only characters in that string are 0 and 1, so they are somehow in a binary format, and an integer k, and we should return true if every binary code of length k is a substring of s. That means for a given k, we are expected to find all 2 to the power of k different combinations of size k in binary format. So for example, for k3, we should see 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and up to 1, 1, 1 in 2 to the power of 3, 8 different combinations. For example, as you can see here, for k1, there are only 2 to the power of 1, or 2 different combinations, 0 and 1. There could be duplicates, we don't know, but at least for this given string, we can see 0 here and 1 here as well. In another example here, we should expect to see 4 different combinations, 2 to the power of 2. So 0, 1 is there, 1, 1 is there, 1, 0 is there, but we cannot see 0, 0, so it should be a substring of s, remember? So we should return false. So first of all, without doing any computation or without doing the iterations, by knowing the lengths of s and k, let's say this is s, this is the string, and has n characters, the length is n. How many different substring can we extract from this s of size k? So for example, if s has 4 digits like this and k equals 4, we can only have one substring. But if s has 5 characters, we can return 2. So one of them starting from 0 and the other one start from 1. And etc. So for example, if s had 6 characters, then we can, with k of size 4, we can create 3. So there's a pattern here. So for a given s, we can create n minus k plus 1. Since for k, we are having a sliding window of size k, iterating on the s of size n. So without running the code, we already know this is the maximum number of different substrings of size k we can obtain from k. On the other hand, we should expect that we are looking for 2 to the power of k different combinations. So we can first do this check. If n minus k plus 1 is less than 2 to the power of k, that means there's no way that we can obtain that or find the solution. So without running that, let's first remove all edge cases without being worried about all of them. So if the length of s minus k plus 1 is less than 2 to the power of k, we know that there is no way, and then we return false. Otherwise, we are iterating through the string and extract all substrings of size k from that. So let's say I define a my set equals an empty set, or like that. And then for I in the range, the length of s, similar what we defined here, the substring my set dot add, then we add that substring to the set. So my set dot add s starting from k I plus I to I plus k. So this is a substring, and at the end we can simply return. We should expect the number of items in that set should be equal to the 2 to the power of k. So for example, if we have repeated patterns, so since we are using a set here, it won't be considered as a new item. So and at the end, if the number of different combination in that set is 2 to the power of k, that means we already found all different combinations. So we can say the length of my set equals 2 to the power of k. And that's it for today. So betting 90% of the solutions. There are a couple of minor improvement in the code so that you can start using a while loop, for example, and start while checking the length of the s at every iteration. If at some point you already reach that 2 to the power of k, you can break this while loop and you can exit the loop so that return the answer faster. But it might be effective on some cases that the length of s is comparing to the k is so large. So for example, if k is 2 and the length of s is 10 to the power of 5, it is probably it is running it has already found the solution, and so we should break the while loop. But I guess this is already enough for this problem, and hope you enjoyed it.